Hey folks, this is Dan Lattiser, coming to you for Chem-125, Doane University's online course. Today we are doing the interactive advanced concepts for Module 5 or Week 5 of the course. And today's assignment is doing a little experiment in cleaning some oxidized pennies. So I have my little setup here. What we're going to be using is your classic Morton's table salt and some white vinegar. So this is my little setup. I've got some measuring tool, just your regular teaspoon, tablespoon measuring, some distilled white vinegar, some Morton salt, two non-metallic containers, one with water. That will be where the pennies go after they have gone through the salt vinegar compound. We have the bolt, this little bolt here, to drop in after, because after the process goes through, the copper oxide that ends up as a byproduct, or I'm sorry, copper chloride that comes off, will then most likely bind to this whatever this is. I'm not sure what type of metal it is, some kind of stainless or plated. But we have our pennies. As you can see, these ones here are, I don't know if this is too bright. These are fairly oxidized. That's not very good. They're fairly oxidized. They don't have a lot of great color to them, which occurs over time. The positive copper ions attract to the negative oxygen atoms, and it causes oxidation to the outside of the coin, which gives the discoloration. And in comparison, you can see this is a newer penny, which has a much nicer appearance to it. So I will get to this real quick, and then we can take a look. We can take a look at my little chemistry write-up sheet that I did for it. So white vinegar into the non-metallic bowl. We only need about a quarter cup. That should do just fine. One teaspoon here of your good old-fashioned table salt. Going to go in there, and then, well, I'll just use this. I didn't bring a little stir stick, but we want this to fully dissolve. So we're going to stir it up. And what this is doing is we're taking vinegar and salt, and CH3COOH plus NaCl, and we're going to get a hydrochloric acid and a sodium acetate. So we're trying to get, what we're doing is we're getting, I mean, the vinegar's got a lot of water in it, but we're also trying, so we're taking a weak acid and getting a stronger acid with the salt as it creates the hydrochloric acid. It's going to be a very, very small amount, but because I imagine this process would still work with with just the vinegar, but the salt and getting the hydrochloric acid is going to increase the rate that occurs. So we have those, and we're going to let those sit for a second. Well, maybe more than a second, but I can already observe the color changing, actually very, very quick. Within maybe 15 seconds, I'm noticing significant change in the coloration. So what we'll go and do here is take a look. And what we have, or what I was just going over, is that we have our vinegar salt, and as we stir it up and join the two together, we're going to get hydrochloric and sodium acetate. And what we have with our pennies that are being dropped in is we have our 2Cu, copper and oxygen, and the outside of the penny, which has a copper oxide. And as explained before, the copper, the positive atoms are then attached to or attracted to the negative oxygen atoms, causing the oxidation and the coin discoloration. Now, when we have our copper oxide with our hydrochloric, what ends up happening is it creates a copper chloride and water as its byproduct. So we can go back. Not a whole lot of time has passed, but also the important part of this is to make sure that once you've allowed this solution and these pennies to sit, is what you want to do is put them in the water, which is right here, this other bowl, to stop the process and also clean the outside of the pennies of any of the hydrochloric acid and sodium acetate. And because when they get pulled out and they're allowed to oxidize back outside of the solution again, they produce the green, that real green, weird kind of looking, I guess, material over it. I forget the exact name of it. But so as you can see, side by side, those pennies are almost the same now in appearance, and before they were looking pretty ragged. Some of these are taking a little bit longer because they've definitely been through the ringer. So I'm going to go ahead, I'm going to scoop these out. And give them a bath. And then we'll lay a few of these guys out. Just give them a little dab to help them dry a little bit quicker. But there you have it. Now, apparently if I throw this guy in here, then it ends up, I guess, developing some kind of patina with, as a result. of the copper chloride binding to it, which I can't say I'm really seeing. I don't really have an explanation for that. Now, I did notice within the thread it definitely darkened, which is probably the binding, and maybe that's not occurring on the other portions of it, because that thread is not, it's more oxidized and it doesn't have any plating on it. So whatever plating is on here maybe stopping that process from occurring. So there you have it. That's pretty much it. Pretty simple. And again, that is our chemical equation. That was essentially all that was really needed to make it happen. You can throw in your cup of water there as well, and paper towel, stirring stick. But that pretty much does it for the experiment. It was successful in that the pennies definitely changed color. They're about 97% copper. I think there's some zinc and something else in a very small percentage, like a 2 and 1%, and then the 97% copper. So what we saw worked in regards to that. I did not see any coloration change in this, except for, well, you're definitely seeing it on the threading. So that's binding to the threading, the copper chloride. But so I guess it was kind of successful as well. Another cool thing to check out is I don't know the exact chemical reaction to it, but something definitely worth checking out in the future is the use of creating a patina for, like, say you have a really nice knife that you'd like to use for camping or hiking, and a carbon high carbon steel, excuse me, is a great steel, but it tends to be exposed to oxidation. And essentially what you can do is you can treat it in some vinegar to create a patina over the blade. And what you're doing is, I guess, in a way, doing a controlled corrosion of the outer plating of the high carbon steel to protect it from the elements, so it doesn't rust and oxidize quite as easily. So that's something you can look up online. I don't know the exact chemistry behind it, but that's something similar to what we did today, and something you can do to, a little fun project to do in your off time. All right, well, I am definitely out of time, so you guys have a great day. Thanks for watching, and take care.